Hi everyone, and welcome to Level 1 GreenFoot Energy Advisor Training. Today we talk about insulation. As an energy advisor, you are going to be asked many questions. And some of those questions over time you will start to see repeated over and over again. And so really in this segment of the video, it's more like a frequently asked question segment where we're going to ask questions about insulation and discuss a little bit about the responses that you might be able to give to the clients as they ask these questions. So the first question that comes in is from Samuel, and he asks, why is insulation my first step in energy efficiency? Well, that's a great question, Samuel. And a high-performing insulation system will reduce the amount of heat loss through the building's thermal boundary by air leakages and conductive heat loss. By effectively keeping the heat in, you actually reduce the demand placed on the heating system, as it will turn on less and then it will actually run for shorter amounts of time. This will be measured in energy savings every time you look at your heating bill. And further, your home will be much more comfortable as the floors and the ceilings and the walls will actually be a lot warmer. The next question is from Ella, and it reads, where is insulation the most important or useful? Ideally, every surface that is in contact with the outdoor elements, whether that be the air or the ground, should be airtight and insulated from the very bottom of the foundation to the top of the attic. All surfaces should be insulated. Some of the surfaces will call for more insulation than others, but ideally everything should have the minimum level of insulation as you are looking for a continuous layer of insulation around the whole building envelope. The next question here from Lydia is, how is insulation rated? Well, Lydia, that's a great question. To rate insulation, it's the resistance to heat flow that is measured. There are two systems that are labeled on products, the RSI system, or the Résistance Système International, or the R value. The R value is the empirical measurement, whereas the RSI value is the metric measurement used for thermal resistance. Ideally, your building should be insulated to the minimum values listed here. It's highly recommended that you upgrade any of the components that are below the R values listed in this table, as that'll be your greatest benefit. For new constructions or more extensive retrofits or renovations, GreenFoot recommends the following. The next question we have here is from Richard, and it is, why is foundation insulation so important? Even though most of your foundation is buried below ground, there is enough of a temperature difference between the basement, which inside air of around 15 to 22 degrees Celsius, and the outside ground between -5 to 5 degrees Celsius to allow for that conductive heat loss that we mentioned earlier. While the temperature differential is not as extreme as above grade, there's still a significant one to consider. You see, concrete and dirt, they do very little to slow the heat flow through them with an R value of R2. Blake has a great question here. It says, which system is best for me? Well, that's a loaded question, Blake, and it will depend on your application, your short-term and long-term goals, and your needs, and of course your budget. So what we're going to do is look at these systems and describe the advantages of each so that you'll have a better idea of which one to choose. Spray foam is our best performer, as it will expand during the application and stick directly to the surface to insulate, leaving no air gaps or voids. This minimizes heat losses and will prevent condensation and sweating. This also means that the insulation will not shift, settle, or move around over time. Air and moisture will not flow through the foam when applied to the minimum thickness, and it does not support mold growth. This product is ideal for areas with high moisture, complex geometries, with many edges and corners, and where air tightness is of high importance. Its performance is unmatched for foundation insulation, joist ends, slope ceilings, and exposed floors or bonus rooms. Another system is blown fibers, either cellulose or fiberglass. This loose insulation is blown in with a hose and is one of the most economical choices. It performs best in two specific applications. Number one, the attic insulation over a horizontal flat ceiling and the filling up of a finished empty wall without damage. In other words, a drill and fill. Because of its loose nature, it will fall into every hole and gap, leaving minimal voids, making it ideal for topping up the attic space or a wall with minimal cost. Bats are probably the most popular type of insulation here in Atlantic Canada. It is economical and can offer good performance when installed properly and with the right application. Bats can be used effectively to insulate walls above grade in combination with sealed poly and well-detailed house wrap, or in combination with spray foam in some applications. Take a look at this comparison chart as we examine some parameters as it relates to the three insulation systems that we talked about. The purpose of GreenFoot Installation Guide is to offer you some of the most sound advice when talking to your clients. You see, installation is a big thing and there are many products and different applications, and we want to be very clear on some of the best applications and the best choices that you might have. Spray foam is the undisputed king when it comes to basements and crawl spaces due to their high moisture content found below grade. Sprayed under high pressure and due to its expansive effect, the spray foam sticks directly to the concrete and minimizes or eliminates the voids of air pockets that can be found behind the insulation layer that lead to condensation. When applied to a minimum thickness, it will greatly minimize the moisture transferring from the ground and into your foundation walls and floor. In the event of a flood or water infiltration, the foam will not get damaged or support mold growth. Comparatively, fiberglass bats installed below grade will allow for condensation since they are made of entrapped air pockets and will have an airspace behind them. They will sweat, and then once wet, it can lead to reduced performance and a higher risk of mold growth. The insulation will have a limited drying potential as the condensation is present all year long, including the summer. The foundation header is the area of the house that sits on top of the foundation. It consists of the sill plate and the joist ends as well as the rim joist. It's a more complicated geometry as it's often crowded with electrical wires and other penetrations like plumbing and ductwork. Here, spray foam is at the top of the food chain, as it can conform to any irregular patterns and provide that perfect seal with no air pockets or voids behind it. This is one area that needs to be airtight, as to prevent excessive movement of moist air through these spaces and to prevent the rotting of the sill plate. In this application you see here in the foundation header is multiple products applied with a very labor-intensive process to ensure that each one of these joists are sealed properly as to minimize the moisture and heat loss. Spray foam is a great alternative to this. It's much less labor intensive and again can conform to those irregular spaces and provide a better performing insulation and air barrier. In a new construction, the most popular choice for the wall insulation system is fiberglass bats. They are inexpensive and when installed with care can offer really good performance. A house wrap like Tyvek or Typar should be installed on the outside of the building to act as that air barrier with proper detailing as to not allow any rain or water of getting in past the membrane. A vapor barrier should be installed on the inside of the wall to cover the bats and sealed with an acoustical sealant, as you can see here in the black, to prevent any air or moisture from making its way into the wall assembly. When done right, This can provide a high R value with good air tightness. If the budget allows it, spray foam would be a step up in air tightness, as it would seal around every electrical outlet and switch inside the wall cavities. For retrofits or other major renovations where the insides of the walls are taken out, spray foam is a great choice for this, as the spray foam will adhere to and conform to all of the inside structures of the wall. Oftentimes older homes were not made with sheeting goods, but rather with boards, and so there's lots of spaces and things. So spray foam would offer a superior performance in this type of scenario. For a retrofit of older homes where the inside and outside of the wall assembly is finished, then the drill and fill method would be recommended. This involves removing a portion of the siding from the outside and drilling a hole in the exterior of the wall to allow us to fill in the space or the cavity inside of the wall with blown-in insulation fibers. Loose fibers like cellulose or fiberglass are recommended, and they will be injected in and fill up the space. And then a plug can be placed over the opening, and the siding can be just reattached, and it would offer kind of a minimal disturbance. This will provide you with insulated wall with no damage to the external or internal finishes. The effective R value of a typical wood-framed wall such as this is much less than you might think. Because insulation is only installed in the cavities between the framing members, this leaves voids in the insulation layer, namely these studs. Studs, bottom and top plate, headers over windows, and other framing members can account for 20 to 25% of the total surface area of an exterior wall. Because wood has a much lower R value than the insulation material in the cavity, this will lead to an overall reduction of the R value of the whole wall assembly. This is called thermal bridging, where there are breaks in the thermal shell of a building. For example, a typical 2x6 wall with R20 bats will have an effective R value of around R16 or 17. Double studded walls, horizontal strapping, rigid foam boards, Z-girts, and other methods can significantly reduce the effect of thermal bridging. The idea is to have a 100% continuous insulation layer. With slope ceilings, there are many reasons to choose spray foam over other fibrous products. In these instances, the other alternatives will have a tendency to sag or slide down, and they require airspace behind to prevent sweating against the roof sheathing. The airflow, while necessary, will compromise the insulation's effectiveness, as it will wash away some of the heat trapped inside of the bats and will further reduce the limited space available to insulate. Spray foam will provide a perfectly airtight solution that will not move over time and provides much more R value for the same thickness, as space is often limited in these applications. If your attic is already insulated and could benefit from a top-up, then the material of choice is loose fibers such as fiberglass or cellulose. It will be blown in over the existing layer and will fall into every void and gap to provide a continuous layer. It is very cost-effective, and you will notice an improvement right away. Attic ventilation can be assessed and improved at the same time as you preserve roof durability and reduce the potential for ice damming or condensation. In the case of an attic that has little to no insulation to start with, or a new construction or major renovation, there is an approach that will offer superior performance. It consists of using a layer of spray foam to first seal the ceilings and penetrations from air as well as moisture flow, followed by economical blown-in fibers on top to achieve a higher R value for the best of both worlds. Another great example for benefits of spray foam can be seen in overhangs and exposed floors like this one. You see, traditional bat insulation has a tendency to slide down or settle over time, producing an undesirable air gap on the top side of the insulation and under the floor. This leads to a lot of heat loss and certainly cold floors. Spray foam will stick to and seal the underside of the floor so that it will remain warm, and the rest of the space can be filled up using traditional bat insulation to increase that R value.